Morning A7. So this is the second video in the progression of Venn diagrams, and today we're going to build on that, look at some notation, specific language used with Venn diagrams. So please make sure, if you haven't already, that you do Monday's task first. So we're going to start looking at a thing called set notation. So there's a few things that you need to know and a few things that came up in Monday's task that it's worth us recovering again. So the first thing is just to say that what is a set? Well, think of it as a collection of items, like, for example, if you're in set 1, set 2, set 3, it's just a collection of, well, of you guys, really. Remember that we have sets, which are the groups, and then we have elements or members, and those are the things that are inside those groups. So if you think about a standard Venn diagram, that's quite easy to remember because you think about yourself. You are a member of a set, and which set are you in? So there we go. So we're going to look at some new things, and you might need a pencil and paper here to practice. You might need to draw some Venns, but mostly the pencil and paper are going to be used for you writing some of the symbols down and some of the new ways of writing things. So please have a pencil and paper ready. Okay, so the first thing is the brackets. You'll notice here that we don't have standard brackets. We have a bracket that looks curly. That's particularly used in set notation. So think of it as a bracket that kind of does that and then has a sticky outy bit. It looks a bit like a sort of flat bird's face or a man with a very spiky nose, something like that. Anyway, so those are your brackets from now. So please, every time you're using set notation, use a pair of brackets that looks like that. Next. So this is how it's used. So for example, here, when it says A equals, that is the set A. So there's a circle, and that's A. Usually the label is on the outside, but sometimes it can be on the inside. And inside that set are the elements 1, 2, 4, 5, and 8. So inside this circle, if I could, I'm going to have to write really, really small now, are the numbers 1, 2, 4, 5, and 8. Okay? So just to say, the numbers are elements or members, A is the set. Right, so we can use that with Venn diagrams. So set notation is used with Venn diagrams. It is not only for Venn diagrams. So you can collect the information and you can kind of look at a very visual way. Some of you may have used Venn diagrams for other things, for highest common factor, lowest common multiple. You might have used them for probability as well. Those are ways of using a Venn diagram. Okay, so you've got a few things here. You've got the sets. So let's call this one set A and this one set B. So anything I put inside here, so 1, 2, 3, and 4 can go in here, 5, 6, 7, 8, for example. And it just means that we have elements. These are all elements. And they are in either set B or set A. Hopefully that makes a bit more sense. Now, the other thing that you've got on the outside there is this rectangle. And when you see a rectangle, this is called the universal set. So everything that goes within here, everything is in the universal set. Now, there's an awesome symbol. So sometimes you'll see a really big U used for universal, but that gets confusing. So we're actually going to get rid of that, and we're not going to think of that. We're actually going to use this cool symbol, which you will definitely want to practice. It looks like a sort of odd 3. And this is called xi. And xi is the symbol for universal. So for example, if I put universal symbol equals 1, 2, 3, 4, oops, need to put my brackets in. That means that inside this box, and we don't know where, the members or the elements 1, 2, 3, and 4 will feature. We don't know where because we don't know what the set A and set B are actually worth. Okay, so we have xi, this is xi. But we call it universal as well. So we have a crossover, and I know from your work yesterday that you guys did pretty well at reading from Venn diagrams, excluding the technological issues. So we have set A contains the numbers 1, 3, 4, 5, 6, and 7 using set notation. So this is how we'd write it. We've got set A equals, then our curly brackets, 1, 3, 4, 5, 6, and 7. Now, at the moment, we're not quite sure where to put them because we're not sure what goes in here. Okay, so let's just go down a step and let's see what's in set B. So in set B, we've got 2, 4, 7, 8, and 9. Set B. and 2, 4, 7, 8, 9. So those are what they look like now. So there are two numbers in this section here. This is the intersection, and it's what we call a subset. A subset means a part of a set. All right, so already you have set A here, and this is a part of set A. But also, this is set B, and this is also a subset of part B, or set B. Okay. So look, there's our set A. So the numbers that we could put into our set A are 1, 3, 4, 5, 7, 5, let's put them in order, 6, and 7. Try to put them in order if you can. And you'll notice that I've written down the numbers that are in this intersection. I do include those because they're still in this set. In set B, we'll include again the numbers that are in the intersection. We've got 2, 4, 7, 8, and 9. Try to write them in order from smallest to largest if you can. Okay, so we've done that. We've written down what's in each of the sets. So the intersection, like I said, that's the bit that's in both of the circles. So here we have the members or the elements 4 and 7. Now we write that in a particular way. Okay, so the intersection is written, and you'll have to forgive my terrible handwriting here. The intersection is between A. Now that looks like A and B. That is not an N. So don't draw this. Don't draw this. Those are wrong. What this looks like is an upside down U, but without any tails on it. All right. So that is the intersection of A and B. So let's go there one more time. Nice. There we go. All in one loop. The intersection of A and B, and that is written as, down here, the intersection, oh, I did it wrong. Let's do that again. The intersection of A and B is, and remember we do our curly brackets, 4, 7, curly brackets again. And here we've got our intersection of A and B. Remember, we've got A intersection B equals 1, 4. Right, so now the bit that a few of you needed to ask a question about yesterday. So this is worth us going through nice and slowly. A union is the numbers that appear in any of the sets. So right now, as you're looking there, you can see set A and set B. And the union is a list of numbers that is in either A or B and includes the intersection. So in this instance, we would write down all of these numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9 would all feature in the union. And think of it a bit like this. I think I've said this to a few of you today. Think of it as the United Kingdom. The union is bringing together all of the information. So for example, the Union Jack has the flags of England, Scotland, Northern Ireland, and Wales, all mushed into one flag, while the union of the data in a Venn diagram is all of that data within the two sets, and I'll show you which sets that will be in a second, smushed into one. Okay, so here we have the two sets, set A and set B. Now remember that we had the intersection looked like an upside down N. Well, the union looks like a U, like this. Now it's not to be confused with a U. It is not a U, although it's helpful that it sounds like union, doesn't it? So we've got the intersection, the union of A and B equals, spiky curly bracket, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so that is the union of A and B, all of the numbers that are in A and B. Okay, so let's have a little look. Can you pause the computer now and can you write down the union of A and B? And I haven't put in how to write it yet. I want you to write the whole thing including the symbols before the equal sign and the brackets and the numbers that apply. So pause the video and have a go. Okay, so the union of A and B, we have A union B, and it goes 1, 2, 3, 4. Oh, there's no 4. 3, 5, 6, 7, 8, 9, and 10. A union B is 1, 2, 3, 5, 6, 7, 8, 9, 10. All right, so now you're going to do 3 parts for these next couple of questions. You're going to find the names of the, name the sets, which means you're going to write down what is in A and what is in B. You're going to describe the intersections. Remember, the intersection is A intersection B. And name all the unions. You're going to have A union B. So those are the 3 types of questions you're going to answer for this one. You might need to pause it. Let's go back. So the first question, this one here. So this one, I want to write down for me, please, all of the bits that you've just been talking about. What is A? What's in A? What's in B? What's the intersection of A and B, or A intersection B? And what is the union? So what is A union B? Write down your answers. Okay, so let's have a little look together. Ignore the question underneath. I don't know why I didn't put them on 2 separate slides. So we have A equals, curly brackets, 1, try to write them in order, 1, 3, 4, 5, 6, and 8. Let's just double check. There are 6 numbers here. 1, 2, 3, 4, 5, 6 numbers. Yeah, good. And then we have section B, and that, curly brackets, is 2, 4, 5, 6, 7, 8, 9. There are 7 in there, and there are 7 under then. Excellent. Right, there we go. So that's our 2 sets. Then we've got to find the intersection. So A intersection, ooh, make that nice and clear for you. A intersection B is, curly brackets, 4, 5, 8. And the union, so A union B, so remember the union is everything put together. This is going to be quite a lot longer. Curly bracket, I might even run out of space, I think. Is 1, 2, oops, sorry, this one. 1, 2, 3, 4, 5, 6. Now there are 2 6s, 6. Let's go on to the next line. 7, 8, and 9. Let's just double check. 3, 6, 9, 10 numbers all together. 3, 6, 9, 10 numbers there. Good. Close brackets. So set A, set B, A intersection B, and A union B. Right? Now, this is a bit harder. It's got 3 sets now. So have a go, do the same thing. I want to know A equals and B equals. I want to know, now this could take quite a while. I want you to tell me what's between A intersection B. What is B intersection C? What is what is C intersection A? And then the final bit, so this might take a little while. The final bit I want to know is, what is A union B? Now remember, this is not asking you for everything that's on the page. It's only asking you for what's in set A and set B. Do not include things that are in set C. This one, I want you to do B union C. And then I would like you to do A union C. But the last question is, what is in the union of A, B, and C? Okay, pause the video, have a go, see what you can do. All right, let's have a go. So in section A, or set A, I should say, we have 1, 4, 5, and 6. Set B is 2, 6, 7, 8, and 9. I want to just check I've got the right numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, good. And set C, sorry, I forgot that one. Set C would be 3, 5, 6, 7. Now, what's in the intersection between A and B? It's 6. And it's okay just to have one number in there. Intersection B intersection C. Well, that's interesting because that is actually both of these. So we're going to put in here 6 and 7 as the two elements. And then we've got C intersection A. That's this bit here. So we've got 5 and 6. Then we've got the union of A and B. So that's everything that's in A and everything that's in B. So we've got 1, 2, 4. I'm definitely going to run out of space here. 5, 6, 7, 8, and 9. So those are in the union A union B. I'm going to have to move my stuff down. I think I'm going to run out of more space here. There you go. Next one, B union C. So now rub off the ones that we've done. Now we're looking for anything that's in B and anything that's in C. So we've got 2, 3, 5, 6, 7, 8, and 9. Hopefully you've got slightly better planning and you're not running out of space like I am. A union C, I'm just going to move this one down here because it's going to be the longest one. A union C, anything that's between A, anything that's in A or C. Let's go down here. 1, 3, 4, 5, 6, and 7. And finally, anything that is in A, B, or C, the union A union B union C. And that, let's just check, we've got them 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so here we're just going to do brackets 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay?